much, Megan. Thank you, Megan, for asking me to present. Um, Swath grazing or corn grazing or extensive grazing on uh, perennial forages is becoming something that is uh, an economic advantage and a tool that producers can use to make more efficient use of land, labor, resources, and also reduces the amount of manure and other expenses you have when you have cattle feeding over winter in dry lot pens. So with that, we'll get going. Um, with a 1,400 pound cow, or as a base unit, and we've got 100 cows, you can see that they will eat roughly 2.5% of their body weight in dry matter per day. So that would be equating to 35 pounds of dry matter. If you're looking at an animal that is, or the feed is at 30% moisture, something similar to what you have in silage, and it's not uncommon to see that in swath grazing. Corn grazing can get down a little bit lower than that later in the season, but how do you figure out the amount of feed or how much area is going to be needed to graze these animals? Or if you've got a limited amount of acres, how much can you expect these animals to eat, and how many days can you expect this feed to last? So if we've got a 40-acre field and your yield is 3,000 or 3,000, or excuse me, 3 tons or 6,000 pounds, that gives you 240,000 pounds of feed that's available. So if you've got those 100 head eating 5,000 pounds a day overall, then you're going to have enough feed there for roughly 48 days. And the one thing you don't want to do if you're putting out cows into a swath grazing or corn grazing situation is you don't just turn them out and open the gate and let them go. You need to regulate the amount that they're having access to on a daily basis or every 3 days or 5 days, so that they don't pick and choose. And then the last 2/3 of the grazing period, all they're getting is straw or stalks, and the nutrition isn't there that what they require. So we've got a way to figure out, okay, we've got 100 cows. We're going to be in there for about 2 months or a month and a half, excuse me. But what do we do? How do we know what the quality of that feed is when it's sitting out there in the swath or standing? So if it's swath grazing, you want to build a sample that is roughly enough to fill half to 2/3, 3/4 of a bread bag full. So what I suggest with the swath grazing is you go on a diagonal across the swaths from one corner of the quarter or of the 40-acre piece to the other side. And at 20 different locations, you pick 3 or 4 stems from the middle of the swath, put it in the bag. And once that's done, you seal off the bag, get the air out of it, and throw it into the freezer so it's frozen when you submit it for analysis. Dormant or stockpiled grazing, guys that took their first cut of hay, they left the second cut out there because they didn't want to run machinery a second time, leave the manure right where it needs to be. Same thing. Instead of just, picking stems, in this case, you're taking a knife, grabbing a small handful, you cut the stalks off about 4 inches above the ground because that's where the cows will typically stop eating. And 20 locations again, bread bag half to 3/4 full. Now, corn grazing is a little bit tougher. It's difficult to get a good sample without chopping it or grinding it to some extent once you have the samples, but take 6 to 8 plants, cut them off 8 inches to a foot above ground where you expect them to stop eating, grind or chop it, and then again, submit the material in a bread bag. Now, if you're bale grazing using a core sampling tool, you want to sample 20 different bales, getting a core from each, and then submitting that material as well. Now, knowing what to one of the things that really comes into play is, I'm going to switch slides here. I put these in the wrong order. What do you need to test for? Obviously, moisture, protein, the two fibers, acid detergent fiber needed for estimating energy, neutral detergent fiber for determining how much feed these animals will actually consume, your macro minerals, calcium, phosphorus, magnesium, potassium, sodium, and sulfur. I would also suggest that you get the copper, manganese, and zinc tested as well, because with varying weather conditions and moisture conditions, for example, manganese in a wet year, the amount that's mineralized or made available from the soil goes up dramatically, and then your manganese level in the feed goes up. I just finished a set of rations today where it's a custom mineral. They have no manganese in the mineral whatsoever. The other things that need to watch out for, especially, is sulfur for canola. If you've got a canola salvage crop, or if you're using a cocktail mix where you've got a lot of brassicas in it, sulfur levels can be quite high. Light frost, drought conditions, or if you've been grazing on the same piece of land or feeding on the same piece of land for 6, 7, 8 years, definitely get a nitrate test done, even if there is no sign of any kind of damage to the crop. This one doesn't really apply very much to the swath grazing or corn grazing, but in a bale grazing situation, you need to test if you've seen any signs of heating in those bales. They smell like tobacco, they turn brown, they've squatted. Determine the amount of acid detergent in soluble nitrogen. That's the protein that's bound to the fiber and not available to the animal. So you have to adjust that. And the final one is molybdenum. Some areas, especially in the gray wooded soil zone, we're finding that moly levels can be up in that 3-4 parts per million range. That is enough to cause problems with tie up of copper. Same with high sulfur levels, it'll tie up the copper. So what do we want to test for, and how do we want to test it? I gave you all the numbers, what we want to do. Core sampling is always better than grab sampling, but that's not possible in some of these situations. The other thing to really look at is the type of analysis. There's a lot of labs out there that use near infrared spectrometry for everything. The traditional method is by wet chemistry. For me, proteins and fibers, they work out exactly the same, or they're very reliable and comparable between the two. So I've got no problems there. But when you get into the minerals and trace minerals, those need to be done by wet chemistry. So for example, if you were to take the NIR samples, you would think that, the NIR samples, it's overestimating the amount of calcium and phosphorus by about 250 to 300%. So what's the point of having a test result if it's wrong? You're in the wet chemistry with 0.16 calcium, 0.2 phosphorus. You're probably, the top one there, you're going to be adding the same amount of calcium as you do phosphorus. Our calcium in both situations, probably about 3 to 4 ounces, but the reasons for it is different. Your phosphorus level at 0.2 is probably where you want the ration to be. So you want that 2-to-1 calcium phosphorus ratio, therefore you need that extra calcium. Magnesium levels being down at 0.13, higher risk for downer cows and milk fever. So when you do get a test result back, what do you look at? What do you need to see, or what are the important numbers in there? First one is dry matter. When you look at the numbers on a feed test report, you always you always look at the numbers on a dry matter basis. So you got 38.56% dry matter in this corn silage, protein at 8.45, bypass protein at 22%, acid detergent fiber, typically low for corn because 50% of the weight of that crop is the cob and the grain, and the neutral detergent fiber is also lower. Typically, you'll see neutral detergent fiber 15 points, roughly 15 points higher than the acid detergent fiber. Now, neutral detergent fiber, when it gets above 60% in the final ration, or if they're grazing and they've got a lot of fiber in there, 60% of NDF is the point where they have restriction in feed intake. The acid detergent fiber is where we estimate our energy from. And in this case, the total digestible nutrients, they're claiming to be 67%. The charts that I use, I think it's closer to 64. So some of the lab results, you got to look at them and be careful of what's going on. Energy, you've got the number of different systems available because there's different programs out there to determine what the animal needs. I like the TDN system because it's one number, very simple. The other minerals, calcium, copper, phosphorus, potassium, sulfur, magnesium, zinc, iron, manganese, sodium, those are all important. You can see with a 2-to-1 calcium to phosphorus ratio, 0.2% phosphorus is the minimum amount that you want to have in a ration, so that's being met. But you can see we're definitely short of calcium. Sulfur 0.15% is where we want to have it as well in the ration. But if you've got sulfur in the water, that shortfall can be made up that way. Trace minerals usually were someplace between 30 and 50% deficient of what the animal actually needs. And sodium is 39% of the weight of salt. So I really watch the sodium, especially when you've got an area with high sodium content in the water or high salt in the water. You have to add those two levels together to get your final result. From the two that I do not pay much attention to is relative forage quality and relative feed value. You're better off to use the actual results and work it accordingly. Those values were used for exporting alfalfa into the States or a mixed hay quality so that you could get an idea of what it's like without having to look at it. Nitrates, 277 parts per million is low. It's about 0.1%. I don't get excited about nitrates until it gets over 1%. And then moly here at 1.48. If we were at 2.5 or 3% moly or milligrams per kg of moly, then I'd be increasing the amount of copper in the ration, just because 1 part of moly will tie up 7 parts of copper. Now, a feed test result is something that gets you an indication of what's there at that specific point in time. And this was a project we did on evaluating the quality of triticale over time. We started cutting at 35 days after seeding, basically at the 4-leaf stage, and went all the way to full maturity. And you can see with this one, the protein levels went down linearly until you hit a little bit past the milk stage when they started to develop the kernels and actually fill the seed heads. Then you'll see a slight increase in protein content. But again, feed test results are good for the crop at that specific point in time. If you wait a week or 2 weeks, those numbers are going to be completely different. Water quality, another one that is really important when you look at rations. In this case, The well water, 841 milligrams per micrograms per mil or parts per million, 841. That's double the amount of sodium required to meet the animal's requirement. Once you get over that 300 parts per million, cows tend not to eat minerals free choice unless there is some enhancers in there to improve the taste of it. And again, the sulfates at 1400, that's the point where you have to really consider supplementing extra copper because of the high sulfate contents. Now, if sulfur content in the ration exceeds 0.4% in a feedlot ration or 0.55% in a grazing situation or a high forage diet, you can run into problems with polio. Total dissolved solids, again, the higher the TDS, the less the cows are willing to drink. That reduces the amount of feed that they're going to be willing to consume. Therefore, they either lose weight or don't gain as much as what they should. And if they're producing milk without them drinking enough, then your volume of milk goes down. Nitrates, nitrate N in the water sample. This is what you want to have, is something that has BDL or below detection limits, meaning there's nothing there. They're not having the problem with nitrate contamination. So we got the basics done. And so when we look at swath and corn grazing, they'll always eat the heads off the cereal crops first, and they'll eat the cobs. They'll leave the stalks and the stems till later until they can't find any more grain. And as the progression goes along, they switch to the leaves, the tassels, and the awns, and then eventually to the stems and stalks. It's the poorest quality forage, the hardest for them to digest. It takes the most chewing. So it makes sense. It's like a kid at the kitchen table. If you give them a choice between mashed potatoes and Brussels sprouts, they'll always take the potatoes first. Protein and energy content in the different portions of the plant. You can see that for corn, the cob and the leaves typically about the same, stalks down at 4%. And the TDN from the heads or the cobs, that's 80%, 62% from the leaves, which is about the same as what you'd get out of an average quality hay, and then the stalks down to 40%. So protein and energy content from the stalks is no better than what you're going to have in straw. Oops. Bale grazing. The recommendation is to place the bales 30 to 40 feet apart on a grid. This example of the bale with the net wrap still on there shows you two things that you don't want to do. Cows, if they eat the net wrap, it forms a ball in their abomasum and they can die because the digestive system is blocked. So always take the twine, always take the net wrap off if you possibly can. The other thing is, you can see by this picture, the bale's been set on the round portion. What they recommend is to place the bale flat on a flat edge. So the round, it almost looks like a donut sitting there with the top and bottom being flat and the sides being round. Reduces waste to a certain extent. And the reason that you want those bales 30 to 40 feet apart, what you're trying to do is place the bales in areas where soil fertility or production has been reduced, either by a lack of fertility or thin plant stand or some other reason. You want to have the manure and urine to be distributed evenly or relatively evenly in that area so that the nutrients can be used. Now, they're going to take the feed out of a 5-foot round bale, and you'll probably see that material spread out about 15 feet in diameter. So expect some waste. The only thing you can do to prevent that from happening is limit the access to the bales that are available by an electric fence. Have the cows trained as to what an electric fence is before you turn them out. And just try to make them clean up as much as you can without them going very hungry and following the truck or following the tractor or the quad, and use as much as you can. So how much you're going to be losing when you use either swath grazing, corn grazing, or bale grazing, it all depends on how hard you push the cows. If you want them to clean up every stitch of material that's out there, I think that's unrealistic. Once it's been laid on, manured on, defecated on, the cows will not eat it. So there is going to be some inherent waste. The older the feed, the coarser it gets, the higher the waste that you're going to have, and the less willing the animals are to consume the feed. Now, about 10 years ago, Lakeland Applied did a feed waste study for bale grazing, and they found that 20% of the feed that was offered was wasted. Now, you might say, holy cow, that's high, but other methods of feed delivery, if you're using a bale unroller, you're going to lose about 13%. If you're putting bale processing on snow, you're at 19%. If you're processing into bunks, you're virtually just going to lose what doesn't make it into the bunk. Everything else is going to be eaten. And those can be portable bunks that can be moved around as well. And then silage fed on snow, you're probably looking at someplace in that 30 to 35% range. Now, the recommendation that we have overall is to have either a 3 or a 5 day grazing period as the maximum length of time. The people that are really intensive, they'll move their cows and move the fences every day. Now, after the first day is gone, they've cleaned up 75, 80% of the stalks and the leaves. So on the second day, they'll find the rest of the cobs, they'll eat the leaves and the tassels, and start picking on the top parts of the stalks, which are better quality than what's at the bottom. Last day, they're on the stalks alone. And again, I mentioned that was no better than quality than straw. So in that case, if you want them to eat up more of those stalks so you don't have problems in the spring, supplement 50% of the dry feed that they'd take on a daily basis, and feed them something to get them through the morning, which is their biggest meal of the day. Feed them in the morning. By afternoon, you'll see them out there picking on the stalks or on the straw left in swath grazing. So you want to supply extra silage, either hay or grain or a combination of the three, something with higher energy and higher protein, so that it just brings the balance up to average where you need it to be, rather than having the up and down problems, from eating on the first day and eating on the third day, because that's hard on the rumen, hard for them to adjust, and it will potentially cause problems. Stockpiled forages, great stuff. All depends on, what are you actually grazing? If it's an mixed alfalfa grass stand, you wouldn't expect to see much of the leaf material left on the stalk or on the stem for the alfalfa after killing frost. They tend to slough off. If you're looking at some of the other legumes, or even some of the brassicas, the leaves tend to stay on. You get a higher quality forage that they eat. Also depends on soil fertility. What's the weather like? On colder days, I've seen cows at midnight out grazing, which is fairly unusual, but they'll eat until they're full. They want to stay warm. Now, grazing in the snow on a stockpiled forage is a little bit more difficult than you have with swaths or with corn, because they really don't have an idea where the feed is. They've got to find it. So in this situation, you have to watch the behavior of the animal to see if there's too much snow for them to eat. And basically, what you'll see is the animals go along and they'll drop their head and go through the snow. They can graze up to their ears in snow. But if that head goes down and it comes back up, goes back down, comes back up, they're hunting for feed. They're not getting anything. If that head goes down and you can see it bobbing 1 to 2 inches, they're tearing forages off, they're chewing. So you know they're getting their feed. But if it gets to the point where they're bobbing up and down and not having that standing position where their heads are down, it's time to find a different feed source. Grazing cover crops tends to maintain its quality more so than, say, an alfalfa grass stand because they don't slough off the leaves as much. Your turnips, kales, triticales, radishes, any of those brassicas increase the sulfur content in the feed. So I've had samples come back as high as 0.85% this year. That has to be blended off with other feeds. Difficult to do with a grazing cover crop, but that's where you limit their access to feed and move the wire every day. Feed them in the morning with a good quality forage and let them graze in the afternoon because they've got 3 meals in the day. The biggest one is first thing in the morning. It's about 65% of what they'll consume. Again, the second one will be mid-afternoon and then one right as it's getting dark. So if you provide them with that good amount of forage that has that lower sulfate content and they all have access to it, then you know they're not going to gorge themselves on the cover crop and then reducing the amount of problems. Corn grazing, this year yields were average to well above average. The hot, dry conditions definitely made those crops mature more rapidly than normal. With the faster maturity, more starch in the kernels, proteins did not get as high as they usually do. A lot of samples in that 7.5% to 9%, the lower range of average, and a reasonably good energy content. Now, some of the labs, all the energy densities or energy content in the forages are calculated off of formulas. Some use acid detergent fiber, neutral detergent fiber, the oil content, along with a few other things I can't remember off the top of my head. And they're saying some of these reports have come back with TDN values as high as 76%. And I have a real problem with that because 76% TDN is what you'll find in oat grain. So if we take a crop of corn to full maturity, it'll be 50% grain and 50% stalks, leaves, and silk. So corn grain at full maturity is 88% TDN. So you take 50% of that, 44 points will be available from the corn. The other parts will be approximately 45% TDN. A little bit better than straw, but not much. So with mathematical calculations, I'm saying that a lot of times if you see values higher than 66, 67% TDN, then you're really going to have to watch the cows to see that they're not losing condition and dropping weight. Now, quality, I've talked about that a little bit, but this year was a different year where we had lots of moisture for most of the region, first off the start, and that impacts the amount of nutrients that are mineralized or released from the soil and made available to the plants. So phosphorus is taken up only the first 3 weeks of the year. of the growing season. Cold conditions slows down phosphorus release, but with the good moisture content, you're going to have more available to the plants. And this year I'm seeing and what happens is as time goes along, that phosphorus is transferred across to the new leaves. Phosphorus is a driver of metabolism. That's what makes the plant grow. So it just gets moved up to where it's needed. It's used by the plant, and you've got higher total phosphorus content in the plant. And this year, it's 20 to 25% higher than average. So with the higher phosphorus content, if you're throwing out a 1-to-1 or a 2-to-1 mineral, it's not providing enough calcium. And we'll get into this in a little bit more detail when we start looking at some of the rations. So in a lot of these cases where they've used the 2-to-1 previously, it's not working. You need a high calcium, low phosphorus mineral, or maybe even a straight calcium mineral to meet the animal's requirements. The other things that I'm seeing this year from the feed test reports is manganese levels, as I mentioned before, increase when soils have good moisture content. And levels are anywhere from 25 to 400% higher than normal. So when you're getting up into that higher manganese levels, there's times when there's no good reason to put manganese into the mineral, supplemented mineral. You'll need the zinc and you'll need the copper to balance off the trace minerals, but no need for manganese in a number of situations. Magnesium, average to below average, again, with the good growth. Magnesium is taken out throughout the year as the plant grows, but you only have so much available. So the higher the yield, the more diluted the magnesium becomes. Sodium, we talked a little bit about that when we were looking at water and the feed test results, but sodium makes up 39% of the weight of salt. So you need to coordinate between water feed sources and the formulation of the minerals so that they do still consume the mineral as required. In this type of a situation where you do have that high amount of salt or sodium, a lot of times you're going to need someplace around 120 to 150 kilograms per ton of some sort of a filler, wheat midds, distillers grains, something to make that material more enticing because you don't have that salt that brings them in to eat. Something you just have to play with. Now, once you do have the grazing situations under control, with the residual or the trash that's left behind, there's some problems that can occur. One is if you have too much trash on the land, you could have problems with the seeding equipment plugging up the next spring, not getting a good uniform seed bed after you run through with equipment. You also have the organic matter or the plant material behind. It slowly decomposes. And when it decomposes, it needs nitrogen to break down. So there will be a tie-up of some of the nitrogen that's in the soil or what's commercially applied. So take that into consideration as well. If you're putting it out on a perennial forage, you can have areas where you'll see no plant emergence in the spring, especially from the center of the bales because the thatch is just too thick. You can see the following year a lot of bare spots in the field, or you can possibly get a problem with weeds encroaching into the field or establishing themselves. Canada thistle is notorious for establishing in those areas. The only thing you can do in that situation is go over the field with a set of harrows or heavy harrows to break up the trash so that the seedlings can come up, or you can break up the cover so that you don't have problems with the seed drills or the air seeders. But again, every time you start a piece of equipment up, it's going to cost you money. For benefits on winter grazing, you like to see the thatch there. You get better moisture retention. The soil is protected from the wind, and that improves the resistance to loss of moisture or evaporation. You get better nutrient cycling. For example, the work they did at Tremundy in Saskatchewan on a bale grazing situation, they found that 40% more nitrogen is retained when the cows manure and defecate in the field compared to hauling the manure out from the pens. On average, forage yields go up. They were working with Italian ryegrass. In the areas where they bale graze, they were getting 5,500 pounds per acre. And that's a dry area. Italian ryegrass is not known to be the most prolific or productive, but the areas where they did not put the bale grazing on there, yield was only 2,200 pounds per acre. Picture of the sandfoin to the right. What happened there is they left some of the plants with sandfoin. Every third or fourth year, you want to let that crop mature and develop seed heads, because when they go in and start grazing late in the season, seeds drop to the ground, they get kicked into the ground by hoove action, and you get a whole bunch of new plants. So it's a great way to get higher levels of plant maturity or getting the desirable plants into the area, as long as you're doing a good job of grazing management. So advantages, disadvantages, there's always got to be some place where you can save a nickel or a dollar. How do you see the advantages of using any of these grazing techniques without having to haul out the manure, fix pens, run water bowls? Cows will generally eat snow out in the field as long as it is soft, but always have the water bowl available. These reduced costs, the power and everything else, could save you up to 40 cents per head per day. You don't have to start your tractor every day to run the bale processor or the feed wagon. You set up the bales in a grid, or you take a horse or a mechanical horse to move the wire every 3 days. And if you're not using the tractor, that's $140 an hour difference in cost. If you feed a cow throughout the winter in a pen, it's going to, last number I saw, it's going to be about $40 per cow for the cost of hauling that manure out and spreading it in the field. The question is, what crop to plant? What's available to maintain quality in adverse weather or after a freeze up? How many grazing days are you going to get per acre by yield? And the cost associated with growing the different crops. So as an example, I pulled the expected yields as just an average. Somebody can argue very quickly that the 10 tons per acre for corn is not realistic. It should be closer to 15 or 17, but this is just a demonstration of how you have to calculate things out. On average last year, it ran almost $400 an acre to seed corn. If you're seeding a barley or an oat crop, it's generally about $250 an acre. I probably underestimated the yield of the corn. I'm being conservative, and yield for the swath grazing is 7 tons. No different than what you'd get out of silage. So feed intake for that 1,400 pound cow, 30% moisture, will be about 85 pounds per day. So off the corn, you'll get 235 days of grazing per acre, and with the swath grazing, only 164. But if you divide the cost per acre by the number of animal days, your cost for the corn is $1.70. And if you went up to 15 tons, you'd probably be down in that $1.25 to $1.30 range. So it's just a method of calculating your costs. And the same thing on the other side with the swath grazing, you're up at $1.52 an acre a day. And it all depends on what you value the crop at, what you value I'm just working off the input costs. We're not talking anything about what's the value of the corn as silage or the green feed. We're talking about just input costs and what it's costing you per day. So to me, that's the cornerstone of the whole discussion is what crops grow well in your area? What do you need for growth and yield to make it profitable? Now I'm going to switch gears. I'm going to go into the side of nutrition. A little bit less detail in some situations, but enough to get the message across. So when you have a cow or any animal on the farm, you've got this is a trace minerals schematic, and you can apply this to any of the other nutrients as well. The first thing that you're going to lose when you don't feed that animal properly is immunity and enzyme function. And enzyme function is related to metabolic efficiency and how much nutrients they can get out of the material. Your production and reproduction starts to suffer after you lose immunity and enzyme function. Reduced average daily gain. Cows aren't going to gain as much weight or retain as much weight. Reproduction levels go down. Where NRC comes in with their recommendations is the minimal amounts to keep things going. And to me, a lot of those numbers are too low for what you have in real world. You get into the deficiency symptoms when they get below that level. The big thing is it's going to take you any place from 60 to 90 days for those animals to recover from that deficiency to go back up to where they need to be. So this feeding mineral just the last 30 days of pregnancy doesn't really work that well. That you can run into a lot of problems. So when you are looking at something like this, your main considerations is calcium phosphorus 2-to-1 ratio, phosphorus and magnesium minimum of 0.2%. Trace minerals and minerals need to be in balance. And that schematic there with that circle with all those different lines, some people say, well, I've got problems with foot rot, so I'm going to increase my zinc content in the mineral or buy a high boot mineral, high copper, high zinc. But if you follow those lines, if one goes up, it's going to make something else go down. So it's going to interfere with absorption of some of the other minerals and cause an imbalance. Weather comes into play as a big part as well. So when I look at a ration, the first thing I have to do is fill the hole or fill the biggest deficiency that's there. So in this case, the protein was the first nutrient to be limiting. So you raise the protein content. So you fix that problem. The next thing you know, you're going to have problems with energy levels being low. So you fix that one. Next step up is your phosphorus is going to be going up, being limiting. So it continues on and on and on, so that it's always a chore to make sure that everything's in balance to optimize production. Your requirements change with time. Your highest levels of nutrient requirements are roughly 8 weeks after calving. That's when you've got your maximum peak lactation. As that calf grows and the milk production comes down, your requirements go down both for energy and protein. At weaning, you hit the bottom. Once the fetus starts to grow and get bigger in size as the pregnancy develops, those requirements come up. And it's just that annual cycle. And the trick is knowing how to optimize the use of the feed you have so you're not overfeeding and costing yourself more money, but not underfeeding so that you're causing troubles. Rules of thumb that are used: protein and energy for mid, late, and after calving, 7, 9, and 11% on a dry basis, and TDN at 55, 60, and 65. So for example, a lot of the standard hay that's being put up is someplace between 59 and 63% TDN. So that's why you need to either find a high energy forage or you're going to have to supplement with grain. Concerns with not feeding enough energy the last 90 days of pregnancy, and when you're swath grazing and using the corn or the cover crops or the barley, you can see there are times when you don't have enough energy in that ration. When the fellow Bellows and his company went ahead and fed a few pounds of grain a day the last 90 days of pregnancy, the big thing was there was really no difference in calf weight for cows and heifers that were getting the extra supplementation. And the low group with no supplementation, the cows were able to maintain birth weight on those heifers or on the calves, but the heifers, they dropped calf birth weight by 12 pounds, roughly. Smaller calf, okay, I can live with that. But the problem is 60% of those heifers needed to have assistance or had animals pulled because of the heifer's not having the muscle tone or the ability to drop that calf on its own. The other side of it, colostrum is formed any place from 4 to 7 weeks prior to calving. And if you don't have the animal in good condition, they cannot produce the quality or quantity of colostrum that's needed. So this is a US slide. The number 6 is equivalent to a body condition score of 3, and that's where you want your cows to be at calving using the Canadian scale. So you can see that the IgM, or short-term immunity, when that cow was skinny at a body condition of 4, was roughly half. So that animal is 200 pounds lighter than what it should be at calving time. That gives you a lot more problems with the neonatal problems, the pneumonias, the scours, weak calf syndrome. There's other stuff involved with that weak calf syndrome as well, but ability to fight infections and diseases right off the start is impaired. The IgG, or long-term immunity, doesn't get hurt quite as much, but it's still impacted. Milk production on that thin cow, if she hasn't been supplemented during swath grazing or corn grazing to maintain her body condition score, and they're 100 or they're 200 pounds lighter than what they should be, or 200 or one body condition score light, what they'll do is when they don't have the energy coming in the ration and they don't have the ability to stay warm, they'll start mobilizing fat off their backs to produce energy. So for every pound of fat they consume or mobilize, they can produce 7 pounds of milk, and that 7 pounds of milk is equivalent to 1 pound of gain on these very young calves. Slide on the bottom is not quite as easy to see, but at 8 weeks, that's where you get your maximum milk production. The vertical line at 12 weeks is when you get the maximum feed intake. So if you don't have the ability to produce the milk at 8 weeks after, and you drop 2 pounds or 3 pounds or 4 pounds, that loss of milk production carries on through the entire lactation. It's not just the peak that's lost. The ensuing milk production is also lost. So it's important to keep those cows in good condition. Salt and mineral consumption and supplementation, important. There's a number of things to consider. One is selenium. Regulations right now by the Canadian Food Inspection Agency are limiting that to 3 milligrams per head per day. And they say you only can use one source of selenium at a time. Unfortunately, that amount of supplemental selenium in Western Canada is not enough. There's ways to get around that, but I recommend supplying 5 to 7 milligrams per head per day. And a lot of problems disappear. Now, vitamin E and selenium work together like a belt and a pulley. If you have one and not the other, you're not going to benefit everything. So you also have to increase the vitamin E. Under the new Feeds Act, they'll hopefully have it released within the next 2 years. We've been talking about this for the last 10, but some of these restrictions should be lightened. And if they can bring that limit up to 0.5 milligram of selenium per kilogram of dry matter diet, that will make all the difference in the world. Now with seleniums and vitamin A and vitamin E requirements, anything that's been out in the field for 6 months or more, the vitamin A, vitamin D, and vitamin E, or vitamin A and vitamin E precursors are oxidized off. So there's basically no value at that point in time. We know what the vitamin A requirements are. That's pretty straightforward. But E, the current situation is a lot of the feed companies, with vitamin being one of the 2 most expensive nutrients going into a mineral, they cut corners and they're only supplying 1/3 to half of what's required of E. So in this case, we talked about 5 to 7 milligrams of vitamin or of selenium. You need a minimum of 300 IUs of vitamin E per day for pregnant cows, 500 after calving, and for feeder animals, lighter, smaller calves. And that first 2 weeks after the animals are weaned and put into a backgrounding or a feedlot, some recommendations are up to 1,000 IUs per day. Sorry. The biggest question that is out there that I get is, what should I be using for mineral when I'm swath grazing or corn grazing? So let's assume that the material that you're having is 0.3% calcium, 0.25% phosphorus. And this year, that's fairly common. So if you get them to eat all that they can, they'll typically get 41 grams of calcium and 34 grams of phosphorus. So they're getting more than what they need, but the calcium phosphorus ratio is only at 1.2 to 1. So it's not high enough. If you add a 1-to-1 mineral to this situation, 100 grams intake is where a lot of them are. All the minerals are pretty well set at 100 gram intake. So using a 1-to-1 mineral, we're actually making the situation worse because your phosphorus levels are going up, and it's making things worse. A 2-to-1 mineral, it helps a little bit, but not good enough to where it needs to be. So with a 23/6, basically a 4-to-1 mineral, you're getting just above the minimum. You need a minimum of 1.5 to 1 calcium to phosphorus ratio. What I'm seeing is some of the feedlot minerals basically have no phosphorus in it whatsoever. So there are corn grazing and swath grazing minerals that are almost all calcium and no phosphorus. And this one, 28% calcium, 0% phosphorus. That brings your calcium to phosphorus ratio back into line. Problem with the high calcium minerals, they're very dusty, they're chalky, they dry out the mouth, and very flat tasting. I worked in a feed mill for a while, and the one time I forgot to put my dust mask on, so I'm not speaking cow. This is from experience. The other thing that people like to do when they put cattle out onto the swath grazing or corn grazing as a supplement is they put out a lick tub or a block. So when you get the situation in the late grazing season, when the grass is over mature for the dormant season grazing, or when they're grazing the corn or the swaths for the second, third, fourth, fifth day, the protein's going to be short. And if there's no way to supplement with grain or hay, this is one option. Urea is a protein source, and one is partial supplies part of the protein in these tubs. And if you get too much urea or non-protein nitrogen consumed, the animals could go off feed. You can run into problems with urea toxicosis as well. So my concern with these free choice supplements, concerns are on which animal is eating how much, how many are getting nothing, how many are getting 3 times the amount that they need. So if you are using these urea supplements, minimum of 0.15% sulfur, that's so they can synthesize the amino acids. They need 2 to 3 pounds of grain a day, and you don't want to exceed 25% of the total ration as non-protein nitrogen are coming from urea. And calves under 450 pounds, their digestive system isn't developed enough, so don't use it for the very small calves. Tubs, supplements. There's almost everything that you want is available. What are your costs? So I've got some numbers here that I took off the website with Alberta Agriculture for some of the grain products, canola meal, field peas, distillers grains, peas. So you have to work it backwards, no different than what you did with how many acre days and what's it costing you to graze for that day. How much are you paying for a pound of protein? Canola meal, 38% protein, same as dried distillers grains, cost of $516 a ton. If you divide that by the number of pounds of protein in that ration, it's costing you 61 cents. Field peas, $3.40 a ton, 63.5 cents, roughly. You get into the other side of this equation, protein tubs, 27.5% protein on a dry basis, $139 for a $220 tub. If you're looking only at the protein content as a weather vane or a way to evaluate it, that stuff is $2.52 a pound. Liquid molasses, 53% protein on a dry basis because you got 60% dry matter, 40% water, but back up in that 60 cents per pound. No different than for the canola meal and for the peas. So you have to do the math to figure out where you're at and what it's costing you to get a product in. Finding pea screenings, finding rejected pinto beans or some other feed product that may give you the opportunity to go ahead and get something that's less expensive. Okay, so molasses on straw, they're putting on 70 to 100 pounds per round bale. It's going to cost you $25 to $36. Last year, a lot of this on. This year, I haven't heard anything. There's feeds more available. With the label, this is just a common label, a 32% liquid supplement. What are you actually getting out of that? You're getting your protein increases with either 1.5 or 2, with the different rates of protein being provided. It's definitely going to increase the protein. Energy value, putting that extra pound of molasses into the ration per head per day, or excuse me, 2 pounds per head per day, you're only getting as much energy as about half a pound of barley. Calcium, phosphorus, very minimal in them. Magnesium, very minimal in most of these products because they're hard to keep in suspension and therefore they can't get the registrations. They can sell the product. And unfortunately, some people think I'll throw out a block. That's all I need to do. So a cow getting 20 pounds of straw 1.2 1.4 pounds of molasses, you're going to need to feed another 12 pounds of barley or 13.5 pounds of oats to meet energy requirements. You're going to need limestone, magnesium oxide, extra vitamin E, and free choicing a 1-to-1 mineral, a 2-to-1 mineral will not work. You need the calcium. So that's that 4 ounces. Supplementation of salt and mineral. Cows will, some days they'll come for the salt and mineral, some days they won't. Consumption is any place from 1 gram per day up to 774. That's 1.5 pounds at one shot. So it may be disappearing, but again, is the right animal, how is that being distributed amongst the herd? Rough rules of thumb, loose product always has a higher consumption rate than blocks. 75% of the mineral consumption occurs at night. So put a salt station or a mineral station where the cows are loafing. Always we, keep one by the water as well. That's never going to hurt. But a couple of rules of thumb, 100 cows should go through a bag of salt per week, and that's 55 pounds. 250 cows should go through 1 bag of mineral per day if the consumption is 100 grams per day. Cows crave salt. They don't crave mineral. They don't have the nutritional wisdom to know what they need. So always mix the salt and mineral together instead of having salt in one place and the mineral in the other, because they'll go for the salt, they won't go for the mineral. What to use? Red or blue salt. There's no copper, manganese, zinc, or selenium in it. We're deficient in those in all of Western Canada. We talked about reproduction, immunity, and growth rates. It's not going to, changing from a blue salt to a fortified trace mineral salt with selenium over the summer, 25 pounds difference in the weaning weight of the calves. You can use these for courses, but do not feed the TM salt with selenium to sheep because there is a high copper content. A previous meeting, there was quite a discussion that went on to see which form of mineral is the best. Do you need a chelate? Do you need a proteinate? Where the inorganic minerals work? And some of the other people in the crowd will said, well, my company is telling, or the company Ideal was saying, I'm going to get 40% improved efficiency by going with a chelated product. That is something that they probably cherry picked out of the research that was done, because your bioavailability, organics, your sulfates and oxides versus the chelates, the proteinate, the amino acid complexes, the amount that is improved in absorption depends on what the previous nutrition program was and what was being supplemented. If the cow's in mid-pregnancy, late pregnancy, or after calving, it also makes a big difference, because as the requirements go up, you have to supplement more. If they're short, they will take more of the chelated products in. The one thing that you have to watch out for is there are products on the market. I found this out 2 weeks ago where the label indicated that there was a chelate in the mineral. And when I got the mixing sheet for that mineral, and if you want to know what's in your mineral products, you can ask for the mix sheet to know exactly what's in there. That product did not have any chelate in it whatsoever. So try to establish what percentage is in chelate form versus the inorganic form. This is a moving target, so be cautious when you go ahead and look at the different minerals and products that are available. You have to evaluate it on your own farm in your own situation. So, as I just mentioned, each situation is different. Feed quality will change from year to year. Therefore, your nutrition program has to adjust accordingly. Feed to what the animal needs at the stage of production. So if you can mix in some cheaper, lower quality feeds during mid-pregnancy, do so. It's going to save you money. The big thing is watch the body condition score. And it's hard to do that when you see your cows every day. have a neighbor come over for a coffee every 2 months, or, roughly 5, 6, or any place from 6 to 8 weeks. Then walk the cows. And he would be able to pick up the difference for what's the changes in body condition are easier than you, because he hasn't seen those cows for a while. If you're not sure, you got the forage associations, you've got private industry people, you've got a feed company, nutritionists, ask for help. And the other thing that is always essential in any of these situations is it's a three-way conversation. Your veterinarian, the producer, and the nutritionist always have to work on us together. It's not a two-legged tripod, because if you do that, it's always going to fall over no matter what you do. So with that, Megan, I am going to stop there, and we can ask for questions. I apologize for going a little bit over my time allotment.
Perfect. Thank you, Barry. I guess if anybody has any questions, you can type them in the Q&A box or in the chat.
I hope I didn't put everybody to sleep.
Oh, we have one hand raised. I can unmute you, Brett, and you can ask your question.
Oh.
You should be unmuted now, Brett, if you want to, or you should be able to speak if you want to unmute. You can ask your question.
Okay, is it working now?
Yes.
All right, on. I had an interesting experience this year with the corn grazing. My cows, I sent them into the corn with probably 7 days, I want to say maybe a little bit more, of forage available. It was like in those -30s, -40s there in mid-December. I had a thinner cow went on acidosis, grain overload, due to the combinations of issues, something guys really need to watch out for. I know if Barry wants to comment on that.
You hit the nail right on the head. If you want to take it a little bit further, Brett, one of the first guys that I met that was corn grazing, this is back 25 years ago, he was told that he could just turn the fence in, or open up the gate and let the cows in and let them graze. It was a 40-acre piece. In about 2 months' time, they had cleaned up all the cobs in the first week to a week and a half. After that, they were just on the stalks. Those cows had lost 200 to 250 pounds minimum. They had real problems with calving difficulties, and 40% of the cows did not conceive a calf during breeding season. So you're exactly right. You've got to limit the amount of feed that they have access to at one time to try to keep the quality of that ration level, so that they don't have those ups and downs with proteins and fiber digestibilities or high levels of starch, and then you get your acidosis or grain overload problems. It's a real balancing act, and it takes a little time to really figure it all out.
I'd like to add to that. So moving into the next paddock, we were really keen on cleaning up. We were just using some hay to get them to clean up, but the next day immediately turned them in, their stomachs were empty, and then another cow acidosis again 2 days later.
Yeah.
And management, there's lots of little things guys got to pay attention to if they don't want to lose cows.
It is definitely a learning experience. I equate this to the mid-60s when farmers were starting to grow canola. They went ahead and tried it. Some of them had complete wrecks. Others only seeded 20 or 30 acres to see what it was like. And that's what I'm suggesting here is, if you're just learning how to swath graze or corn graze, start off slow and learn as you go so that you don't have, a number of cows that died or 40% open cow rates. It is a definite learning experience for sure.
I had a good article from Saskatchewan University. I can give it to Kelly. I'll email it to her right now and she could share it with anybody who wants it. It's the document I should have had in my hands before I started.
Thanks, Brett, for that question and your comments. It is quite the learning curve. So we do have a couple of questions in the Q&A. So someone asked, would you be able to go back to the slide on the brown and green minerals? I missed what you said about using them instead of blue or red.
Okay, with the traditional blue salt or red salt, the red salt has iodine, the blue salt has cobalt and iodine as added nutrients. The red color comes from red food coloring or iron oxide. The blue food coloring comes from, or blue color comes from blue food coloring. There's no copper, manganese, zinc, or selenium in those red or blue salt blocks or loose products. So the brown or the green, which is called a high trace mineral or a fortified trace mineral salt with selenium, copper is typically in the range of 2,500 ppm or milligrams per kg, manganese at 5,000 and zinc at 7,500. There's others that are going up to 12,000 of zinc. They start off at about 4,500 copper. Some of them, depends on how much they're willing to eat. They're good. Your selenium content in these brown or greens is 120 milligrams per kg. So improved cow metabolic efficiency, they're going to be able to produce more milk. I mentioned before the grazing situation with calves in the summertime, 25 pounds of increased weight gain on the calves. They didn't measure the cows, but they thought they saw something with having higher reproductive efficiency on the cows as well. And that makes sense. So is that what you were looking for?
We have another question. So Adam asked, in our area, we have very high iron in the water. Short of a water sample, what would you recommend to counteract that high value? Or is it not negligible to worry about? Also, how do you feel about Sicer milk vetch for winter grazing?
Iron, give me 30 seconds here. Okay. When your total iron content in the ration, including water, exceeds 1,000 parts per million, then you're going to have mineral tie-up. So the adequate levels at 100 to 500 ppm is where I like to keep it. And yes, it will. Interactions, cobalt, copper, manganese, selenium, zinc. Deficiencies can be induced by high iron content. 300 ppm iron can reduce copper absorption. More infectious diseases, which causes fevers, reduces iron serum levels, and you need a higher level of manganese in there because iron does tie up manganese as well. So I'm taking that out of the book I use as a reference. I can't remember all of those things, but yes, iron is something to be concerned about. Test your water, definitely, and then run it through cow bites or run it through a ration balancing program to see if you have to modify your levels of the trace minerals in the supplement. Now, the second question was on, if you can help me out there, Megan.
It's, how do you feel about Sicer milk vetch for winter grazing?
Sicer milk vetch will typically keep its leaves on better than alfalfa, but if you get a good windstorm, a lot of those leaves will go on the ground. I do like it being mature for a winter grazing about once every 5 years, because when they go through there and graze it, they may not get as much as you would with some of the other grassy types, but it knocks the seeds out of the seed pods. Those get worked into the ground and you get a natural seeding of the Sicer. And over years, you can see the concentration or the density of that Sicer in that stand will go up with time.
Perfect. Thank you, Barry. We have one more question. Any information on sandfoin and how it will grow? Is it a good alternative? Will it help regenerate soil?
It is a good crop to grow. Sicer will grow in some areas and somewhere it doesn't. I remember driving in through around Smoky Lake up through that neck of the woods, and the Sicer milk vetch was just thick in the ditches. So if you can see it in the ditches, then you've got a really good chance of getting it in the stand as well. It is a non-bloat legume. So if you are pushing cattle for higher performance with a higher legume stand and grazing it, having Sicer milk vetch in there will definitely reduce the risk of bloat.
And we have another question. So Brad says, I made hay this summer out of volunteer canola while in full bloom. It was approximately 70% canola mixed with underseeded oats and grass. I fed it to the cows through a bale shredder. The cows preferred it over the alfalfa mixed hay. Are there any concerns I should have had in mind when feeding this?
Well, the first one is putting a bale of canola green feed through a bale processor. It's no different than putting it through a combine. All that, a fair portion of that leaf material, depends on how the machine was set. You're going to lose a lot of protein, a lot of the energy. That's the high quality portion of the ration or of the feed. The big concern for me is what was the sulfur, or what is the sulfur content in that feed. If it's above 0.4%, that's where my comfort level is. Then you're going to have to start mixing it off with something else so you don't have a polio problem. Now, do you mind if I take 3 seconds and explain how polio works?
Yeah, for sure. Brad just says it was at 0.31%.
Okay, so at 0.31%, he could feed it as the entire ration, no problems there. I would expect the calcium levels would have been fairly high, just because it is a brassica, bigger taproot that'll get down and get more calcium. But no, it's a good feed. 1988 was the first time I saw guys feeding salvage canola crops to cattle as a in a drought situation. So it works. It's just a lot of guys, if you have to salvage, or if you've got a first year stand and you got to volunteer, cut it and feed it at that, or cut it at that full bloom early pod stage, and you'll get quality of feed that's similar to a high-end alfalfa grass hay. So it is good stuff. Now with polio, what they found is the hydrogen or the sulfur in the feed, when it gets wet, turns into hydrogen sulfide. That goes to the top of the rumen. It goes through the rumen wall and gets into the lungs. Hydrogen sulfide works in a similar manner as nitrates, where it limits the amount of oxygen that can be carried in the blood. And when you get that reduction of oxygen availability, the highest metabolic tissues in the body are the first ones to be affected. In the brain, highest metabolic activity of all of the tissues. So once the brain becomes short of oxygen, then you run into the polio problems.
Perfect. Thanks for explaining that, Barry. Brad said, I fed it along the feed bunker and they licked the ground clean.
That makes sense. It is a preferred feed. I've seen guys put out bales of canola green feed or, salvage. And the cows would clean that up before a nice green bale of alfalfa grass hay. I totally agree.
Well, I think that's the end of the questions. Thank you so much, Barry, for tonight and for your presentation. I think everybody learned quite a bit. And with that, thank you everybody for attending. And yeah, if you have any more questions, you can either contact Barry or you can contact us at Lara and we can get a hold of Barry for you. Also, this webinar is being recorded and it will be up on our Lara website and our Lara YouTube page within the next couple days or week. So thank you, everybody, and have a good night.